Okay, so in this video, we're going to look at how to simulate wind movement, something that kind of looks like this in plan or in elevation, and kind of gives us the pressure and the speed and the direction of the wind vectors around a build surface. So for that, I have a very simple form here. For demo's sake, I have a poly surface, which you might have, and I have a exploded mesh, which you might have if you have taken the geometry from SketchUp. Right, for this, first I'm going to do is join it. Okay, and we just need to get it ready. Please make sure that you're working on meters. So if you have this, you can always save this file. I'm saving this as wind demo, and yeah, that's on my desktop. So once you have done this, we will go to this online free simulation web app known as SimScale. So you can log in here and have, like, maybe use your college ID to sort of have your login created immediately. Every ID gives you 10 free simulations. So I already have something here, but let's start from something new. So once you have something like this, you can go to new project and just write some name or simulation 1. Project category, these are compulsory, so it comes under AEC. AEC stands for architecture, engineering and construction, and I think that's okay. I can let it be public and create. Once you have this, you'll have the whole interface load up, uh, and it's straight away asks to import, so it accepts Rhino. So I'm going to start import from computer, and I'm going to go to I don't know if I've saved it or not. I'll just save it once again, and I'll go to import from computer, wind demo. Okay, and you can import it. It's going to take a few seconds, and it's going to load up here. Now the only thing is this the interface is slightly weird because you have to sort of get used to it. It's left click dragging, unlike right click dragging that happens in Rhino, to sort of an orbit. And before we get further, we have to go into editor copy because you have to create a volume of air. Also, the weird thing about it is the zooming is inverted, which is a little irritating, but you'll get used to it. And there is this thing that you can always see to sort of orient this properly using this tiny little tool. So anyway, we have two geometries imported. What we need to create right now is two things. First, we'll create like this volume of air around it, and then we'll scoop out this from that volume of air. So you'll see in a bit, this loads up. You can go to editor copy and it will open a small CAD editor. But once you are in this CAD editor, you can go to flow volume and external volume. Okay, so if I go to external volume, it creates this huge volume. The only thing is we need to work on these dimensions. I'm going to put 0 because the 0 is the ground, Z. And another thing is I will actually not need it that high. I'll put it, let's say 100, maybe 80. Let's keep it 100. Too much is not required and too less might result in inaccuracy. For this, I'm going to put minus 100 and plus 100, and this also minus 100 and plus 100. Okay, now that I have my flow volume, I can actually put apply. Okay, and now you see that you will not be able to see anything inside. It's opaque. It's entirely air. So you can go here and change the render mode into, let's say, wireframe. Now the second thing we go before we get into simulation is we need to scoop out your building. So basically, unlike any other simulation, we are not building or modeling the building itself. We are modeling air around it. So right now what we have are these two blocks which are actual models. We are going to use that to scoop or subtract out of this tiny, of this giant air volume. So how do we do that? We're going to go into Boolean and we're going to go to subtract. Okay, so this and this says that target body and the tool body. The target body is that entire volume, and the tool body is what is the cutting part. So the cutting part is these two volumes. Okay, and I don't need to keep these tools. So once I've scooped out those tools, I will discard it. I don't need. I only need to keep the air around it. So I'll sort of hide this, and then for this I'll click here and I'll select this and this. Okay, so two things are there, solid 6 and solid 3, and I can apply, and let's see what happens. Now nothing will happen because those two are removed, but you've already hidden the air. So if I go here, you'll see that you have scooped out two buildings depending on your whatever your mass is. Please don't please don't model extra things like complex things like trees or tiny details like on the landscape and walls. Try making the build the larger volume. Don't model the plane. This is basically in Rhino. I don't have any tree, I don't have any plane. This should be a standalone model in meters around the origin, so that's ideal. Okay, coming back here, I'll just change it to wireframe mode, and then I think we are done to take it out of the CAD mode and then get it to actual simulation. So I'm going to click save on the top right, and now we have here we will go to create simulation. Okay, so create simulation asks for a lot of these things. We're only going to go for incompressible fluid flow. That's you can always see this. This is a little different. This is also not free, but this you can see a building and wind around it. So I can click on it and create simulation, and it's going to list down the options that are responsible to create the simulation. Okay. Okay, now we're going to go into each of these, and the red ones are the ones we have to look into. Okay, so the green is fine, the geometry is fine. The material. So once we go into the material, the primary material in wind simulation here is air. So I'm going to go and select air, and then click apply. And so it's as easy. Now it turns green and we can move ahead. The flow region is assigned automatically. This is the only geometry here. Ideally, you should just have one flow region. Everything else is removed. It's just the air. Boundary conditions are already ticked. I don't have to do here. Now, sorry, initial conditions are ready. We don't have to do anything. With boundary conditions, we have to do three things. First is the velocity inlet. So for larger buildings, there's going to be one inlet, and there's going to be a pressure outlet on uh, all the three sides and also the top side, and the bottom is going to act as a wall. Okay, we're going to look into it one by one. Coming back to this, if you look here, let's say my direction is this, right? My wind direction is this. Coming back here, my wind direction is this side. If you look at this uh, axis, it says that x-axis, and let's say my wind direction is sort of x-axis. So please check from your you cannot rotate it later, but you please check what is your wind direction as per your wind chart. So you for this you can go here in Climate Studio, and take some time to load. I'll open this, and okay, I'll go to wind and I'll show the wind rows, and for Bangalore it shows that it is primarily southwest, so make sure you align the building accordingly, or otherwise there'll be problems. So there's going to be one simulation from here which is probably from the east, it's going to be this time, and from the other is going to be probably somewhere here, right? So during April to July, you can see that it's primarily from the southwest or west. So I'm going to model this in the x-axis. Okay, so for that, velocity inlet, it's going to ask for a wall first of all. So this is my direction. So I'm going to click here, and also please see that what and which direction you're entering the wind velocity. Okay, uh, it's the x-axis for me. This also coincides with this, sort of like an x-axis. So I'll enter. How much to enter? Now here it says some speeds. If I go and print here, it will say some speeds. Maximum speed around is uh, let's say 8 meters per second. But there is also the IS code, which gives even higher speeds. Right, these are peak speeds during hurricanes. So if you look at this map, this probably might not be visible right now, but if you look at this area, Bangalore, it comes around to be 33 meters per second. So it's better to be safe, on the safe side. Instead of taking this 5 meter or 10 meter per second, I'm going to take this uh, in this area. It says that 33 meter per second. Just type India wind map, IS code 875, and you'll get this map, which is around Bangalore is 33. So I'm going to type, I'm going to go here and type 33. Okay, so it kind of shows this, and I'm going to click on this. And so this is done. You can see this icon and this arrow. Now I have pressure outlets instead of wind outlets. I don't know the wind speed of the outlet, but I can make sure that the pressure around is zero. And that's how Bernoulli's principle works. So I'm going to select all of these walls. Okay, should be 1, 2, 3, 4 regions, and the pressure is zero. And so that's where the pressure difference is going to be created. At the inlet, the pressure is going to be calculated based on this area of your this thing, and the rest of them is pressure zero. So there's going to be wind moving because of this pressure difference. I'm going to click this, simple, done. It shows that pressure outlets are 4 faces and wind inlet is 1 face. Okay, and lastly, the bottom is where nothing happens actually. It's the ground. So I'm going to click here, go to wall, and then make sure you select slip wall. Now slip wall means the air kind of the air kind of moves along the surface. So we're going to look at slip wall. So air is not restricted. It sort of moves along the surface. I'm going to look at the bottom, and this is a slip wall, so that's fine. And click here, and now that is done. And so most of these things are done, and now I am going to go and click the or run the simulation. That's all. It's going to take 11 to 26 minutes, and I'm going to call it iteration 1. Okay, we start this and I'll see you within this time. It's going to compute, and I'll see you in a bit. Alright, so we are back, and it took 16 minutes. The best thing is, if it's longer, you can just go and do your work. You will literally receive a mail notification that your simulation is up, because it's all cloud-based. Now, once this is done, I can go to post-process results. And it's going to take some time to load up the entire thing. But let's see what we have here. Now, the thing is, first of all, we don't need to actually see the volume. So I'm gonna go here and select this volume and hide it. But if you do this, everything's going to be gone. So instead of that, I'm going to right click show all, and instead of hiding the entire volume, I can hide faces. So instead of this, I'm going to go to select face, and I'm going to hide basically the 6 faces. I'm gonna yeah, and I can go hide selection, and also this as well. So I can right click and Yeah, so now I can only see the void. These are actually not buildings, these are just the faces of the air volume, but you can imagine it to be buildings. Now I can go to uh, this elevation. Now always the wind simulation works on planes. It's better because it's a lot of points in the air and a lot of data, so it's better to sort of understand it through planes. Now I can actually rotate the plane. So if I go like this, I go to cutting plane, uh, I can change my position. Now this doesn't really work, but X and Y work. Actually, Z doesn't make sense. So that is through elevation, but what if we do it in plan? So if I go to orientation and go to Z, now you can see that it's too high. So I can sort of reduce the Z here. And you can see these colors coming up. I can go to top and you can see these different, you can take a screenshot somewhere it is here. And once you take adjust this thing, you can switch on, the only thing is there's going to be the SimScale watermark is going to be there, but you can take a screenshot. And once you go back to your simulation, it adds the screenshot here. You can go here and download. Okay, but the interesting thing you see here is in this cutting plane, you can see the velocity magnitude. You can see that the velocity is sort of lesser in these parts and the higher in somewhere, to the right of this building and somewhere here. You can also see the vectors. Now the vectors are these lines, are these arrows that point and give you a direction. And if this is too much, you can always change the grid spacing. You can change the scale factor as well, make them a little smaller. Okay, I'm going to make it point, let's say 1, and I can increase the grid spacing. So I'm going to put it, let's say 0.1. This is too less, 0.05. Yeah, so kind of gives you some idea. You can always also go into pressure. Okay, so pressure will give you a lot of these things. Now in pressure, you will see that there is a lot of negative pressure. With velocity, there's going to be, I mean, there's no point of a, it's a vector, there's no negative vector, so there's no velocity negative. But in pressure, it's a scalar, and you can see that there is a lot of negative pressure on the right side, just behind the building, and the green areas is where it's going to be, the green, yellow, orange, and red is where there's going to be high pressure, and it works in Pascal. So you can also take the screenshot. This helps us locate basically areas of negative pressure. That means they're going to be what we call as uh, eddies. So wind is going to come in, sort of have like a small whirlpool here. Let's just again, I understand it through velocity and velocity magnitude. So yeah, something like this. And if you increase the or decrease the grid spacing, you'll understand what I'm saying. You'll see that if I zoom in here, right, I can also switch off the color. Yeah, you can switch off the color, but it's just better to sort of have it something like this. And you can see how this arrows kind of turn around, and they lead to something known as eddies. Basically, it's sort of like this negative pressure zone that kind of has this tiny whirlpools. You can see here wind is in this direction, and that's why this is going to be these sort of these uh, negative, eddies coming up. So but yeah, overall you can, uh, it's a fantastic way to sort of get an idea that if you're planning, let's say, a venture or how your site wind is working, uh, it's a great simple tool to sort of get uh, wind simulation done very easily without installing any software. Okay, just one more thing. If you want to have an indoor simulation, it's slightly more complex, the Rhino modeling. what you need to do is you need to work on these Boolean commands, which is Boolean union, Boolean difference, Boolean split. So once you have a solid box, don't work with, if you look at this, it's a closed solid polysurface, so you have to work with all these solid tools. Don't work with meshes, don't work with open or trimmed surfaces or polysurfaces. This has to work with solids, otherwise it's very easy to get it wrong. And once you get to this, it's pretty similar that you're going to have that one area which is going to be your inlet. There are going to be 4 outlets, pressure outlets, and then there's going to be a wall. The wall is at the below. So same thing, but the modeling here is a bit complex. So that's all I would like to add.